Hello, everyone. Thank you for joining today to discuss about data modeling with Amazon DocumentDB. My name is Mihail Doiu, and I'm a specialist solutions architect for Amazon DocumentDB at Amazon Web Services. One of the most common topics raised by our customers is how to model the data and what are the best practices for schema design when developing an application using Amazon DocumentDB or a Nosql database in general. In this webinar, I'll discuss about key considerations to have in mind the different approach when it comes to Nosql data modeling, but also similarities with the relational model, like the embedded versus the reference approach, which in essence is another way of saying the denormalized model versus normalized, which are key concepts in data modeling. I'll also discuss about types of relationships that will give you a better understanding on when to choose between the embedded and reference model. I'll touch on a few schema design patterns, the most useful and common ones I see applied in real life. And of course, I'll mention best practices or things to be aware of when designing the schema model for your applications. With Amazon DocumentDB, data is stored in JSON format, and JSON is one of the most widely used languages because of its simple markup, easy to read format, and lightweight composition, which makes it easily transferable from system to system. JSON is also a common API output in a wide variety of applications. Document-oriented databases are one of the fastest growing categories of NoSQL databases, with the primary reason being the flexibility of the schema. Relational databases store data into unique tables that must be predefined prior to adding or analyzing the data. The structure of these tables is purposely rigid with strict parameters, while document databases store and query data as JSON-like documents, making it easier for developers to store and query data in a database by using the same document model format that they use already in their application code. Document databases also give you the ability to index any field or embedded fields. You can query and store semi-structured and unstructured data. You can run ad hoc queries to address questions that are not able to be solved with predefined datasets. And you can run operational and analytical analytics workloads that depend on the scale and integration of varying data types. Now, Amazon DocumentDB, it's a good fit for a variety of use cases. For example, when thinking of content management, storing content such as news articles or blogs, or recipes are a natural fit for a document model instead of storing the data in the rigid rows and columns of a relational database. In the case of catalogs, we see customers recording outputs of machine learning experiments, inventory descriptions, and pharmaceutical trials using the flexible, intuitive nature of documents to be able to model, capture, or query that type of content. Profile management in gaming is another common use case we see, from collecting game data, storing online profiles, and game management. Documents allow you to evolve the content seamlessly. And for mobile, because many mobile apps already use the JSON format and Amazon DocumentDB stores JSON natively, it makes it easy to store data you are collecting back and forth between these devices. Personalization, it's another use case. Amazon DocumentDB allows for customizing offers based on transaction history or financial data to improve user experiences. Now, why is schema design important if the schema is flexible? Well, in short, because it can have drastic implications when it comes to performance and cost. We typically see anti-patterns, for example, arrays with large number of elements, redundant indexes, and very large documents. What this translates to is fetching or writing the data in a non-optimal way. Commonly, those slow queries that can take hundreds of milliseconds, seconds, or even minutes, which will affect the end user experience. It can also lead to high input-output operations to or from storage, instead of caching the working set in an optimum way. Working set being the indexes in the most frequently accessed data. There are quick fixes to address these issues, usually by throwing more money at the problem, by scaling up, adding bigger instances, or scaling out, adding more instances, but those will be short-term fixes. While reviewing the access patterns, remodeling and applying the right design pattern will provide a long-term and more sustainable solution. And we'll see some of the techniques to address those anti-patterns in this webinar. But first, let's refresh our memory with these two key concepts in regards to data modeling: normalization versus denormalizations. Concepts that apply to relational or non-relational databases. Normalization is a design technique of organizing data into tables in a database. Normalization rules divides larger tables into smaller tables and links them using relationships. The purpose of normalization is to eliminate redundant, repetitive data and ensure data is stored logically and consistently. Now, denormalization, on the other hand, is the opposite of normalized model, where redundancy is implemented intentionally, if you will. Data is combined to have everything in one place. This way, all the needed data is fetched faster without the needs for joins. The downside is that you'll have data duplication and will require some extra checks to maintain the data integrity. The main goal of normalization is to reduce or remove data redundancy, as I was saying, and inconsistency, and also to optimize storage use. Writes are faster in a normalized model because of the smaller documents in multiple tables. Reads, although the reads will be slower due to the number of joins needed to fetch the data. Normalized model is good for OLTP applications, online transaction processing. The main goal of denormalized model is to improve query performance, specifically read performance, as there are less round trips needed to the database and no joins needed to retrieve the data. This model is good for OLAP analysis, online analytical processing. Because the documents can become larger, writes are typically slower. And because of the data duplication, we may see more disk usage as well. Although nowadays, this is not quite a limiting factor. Now, defining a schema in a relational databases is done at table creation time. And you may recognize here the syntax for creating a table in MySQL. You need to define the column names and also the parameters for each one. We end up with a tabular model where data is inserted as rows. Making later changes to this initial schema is not trivial, either if changing the data type accepted for a certain column or if additional columns are needed. Schema changes require a maintenance window, good preparation in advance, and more importantly, some downtime may be required as well. Amazon DocumentDB supports flexible schema. It doesn't require a predefined schema like in a relational database. You can just insert the document with the fields that you want or that are needed by the application. A document field can accept any data type. Same field can have different data types. For example, a field in a document can have an integer as value, but in other document, the same field can have a string as its value. And you can add a new field or modify the type of fields without downtime. In each document independently. For example, in the same collection, I'm adding a new document, an ice cream product, where 2 additional fields are needed, expiry date and ingredients in this case. Well, I don't have to update a schema in the database in order to insert the new document. So this allows to change the document structure as the application evolves. You can iterate faster and be more agile when it comes to application deployment. The Amazon DocumentDB flexible schema gives you so much freedom. However, we will see in this webinar, that doesn't mean some rules, if you will, shouldn't be followed in order to achieve the best performance. Another important consideration for data modeling is the different approaches between relational and non-relational. In the relational world, you start from the data, and typically you structure it using a normalized model into tables, defining the relationships between them. And then you write the application and queries to retrieve that data. In the NoSQL world, you'll start from the application requirements, decide the access pattern and queries, which will define the data model, which in turn will define the way the data is stored. For example, instead of doing joins when you read the data in relational databases, what you're going to do is think about joining the data at the time you write it in a database. This way, your data is retrieved efficiently with less round trips to the database. So the first recommendation I want you to remember from this presentation is design your schema based on the read and write patterns which are particular to your application. Is the workload going to be primarily reads? Probably lean towards a denormalized model. If it's write heavy, then maybe a normalized model is a good approach. 50-50 read to write ratio, a combination of the both models will work very well. Similar to relational or other non-relational databases, when it comes to data modeling, you have 2 options, embedded model or the reference model. At the high level, you can look at embedding as denormalized model, while referencing is the normalized one. So let's deep dive into each one of them. Embedded means you store the data into arrays and objects, subdocuments, within the same parent document. This means documents are all stored under one collection, and whenever you retrieve the parent document, you also retrieve all its embedded documents. This example, for this product, the application requirements states to have the nutrition information on the product page. As this data is needed together, it makes sense to store the nutrition information in the same document. So the takeaway here is, if data is always accessed together, storing it in the same document is optimal. Now, the major advantage with the embedded model is that there are less calls to the database, as all the needed data for an entity, in my example, it was the ice cream product, is retrieved in a single query. Joins can have an additional overhead, and this way we avoid implementing them. As a result, embedding generally provides better performance for operations, as I discussed earlier about the denormalized model. Embedded data model also makes it possible to update related data in a single atomic write operation, because single document writes are ACID compliant with Amazon DocumentDB. However, there are some downsides to take in consideration. Well, if everything is put into one single document, you may end up with large documents. And Amazon DocumentDB has a hard limit of 16 megabytes for a document. Large document sizes also require additional processing and system resources such as I/O, which is also one of the pricing dimensions. With Amazon DocumentDB, write I/O operations are counted in 4 kilobyte units, while read I/O operations are counted in 8 kilobytes units. This is why it's ideal to limit per document size to 8 kilobytes or less for optimal performance and cost. Also, as the documents are larger, the working set, as I mentioned, the indexes and most frequently accessed data, the working set will also be larger, and that will require more memory in order to cache it. Another important downside is that the performance can degrade when using arrays with many elements. And let's take a look at this example, where a decision was made to embed the reviews in the product document. Well, imagine this ice cream is becoming very popular. It can receive an unknown number of reviews. That will increase the document size very quickly. So as a rule, all arrays should not grow without a bound. If you identify a case where arrays can grow without a limit, consider separating that part of the document and apply the reference model, which I will present next. Now, the other option for designing your schema is to reference another piece of data from other collection and join it either by the application, by doing multiple queries, or you can join it at the database level by using the $lookup operator. Referencing works similarly as the join operator in a Nosql query. It allows you to split up data to make more efficient and scalable queries, yet maintaining the relationships between the data. So how is this model going to look in this case? What we are going to do is to split into two collections, one for the product and one for the nutrition information. Now, if you pay attention here, know that in this case, we have a one-to-many relationship, if you will. It's one product with many nutrition documents. We are keeping the reference on the many side. If you look closely, I store the product ID in each nutrition document. But when using references, the growth of the relationship determines where to store the reference. If the number of references is small with limited growth, storing them inside the product document may sometimes be useful. In this case, I'm storing the warehouse information where the product is located. So if I split it, you can keep the reference on the one side, the warehouse document ID respectively. So the advantage with this approach is that data duplication is avoided by not storing the warehouse subdocument in every product. Also, imagine a change is needed to the warehouse. Maybe capacity has changed, for example. You will have to update in every product document. While if you have it separate, it will be just a single document update in the other collection. Now, advantages and downsides with this model. Well, by splitting up the data, you will have smaller documents and less likely to reach the 16 megabyte limit. Also, by not retrieving the data that is not needed on every query, the working set will be smaller, so less memory requirements. And also, we will reduce the amount of data duplication, as I just shown earlier. But on the other hand, there are more queries needed to retrieve the data, and joins can be expensive. In order to retrieve all the data in the reference documents, a minimum of 2 queries, or if you might use the $lookup join, which is required to retrieve all the information. Also, multiple collections means more indexes to manage. That could also cause some overhead. So, as a best practice here, joins may require additional processing resources. Make sure to optimize the document size and indexes. Make sure the additional queries are covered by an index and that the indexes have high selectivity for the best performance. So, based on what I presented so far, how can you choose between the embedded versus the reference model? Well, you will have to start by asking yourself some questions. For example, how often does the embedded information is accessed? Is all the embedded information needed for every query? Is the embedded information updated often? If you are reading and using the majority of the data in a document and its related documents, and data will not grow out unbounded without a limit, prefer the embedded model for simplicity. On the other hand, as your application evolves and becomes more complex, having a monolithic model with one collection may become difficult to manage and harder to develop new features. If a portion of the document is rarely accessed or frequently updated and growing, then consider moving it to a separate collection and follow the reference model. But to help you even more into making this decision, let's talk about types of relationships next. Now, database relationships with Amazon DocumentDB refers to the representation of how multiple documents are logically connected to each other. And make no mistake, we are talking about the same types of relations from the relational databases. For example, we have a users collection. One user can only have one name or one email address. This would be an example of a one-to-one relationship. We can model all one-to-one data as key value pairs in our database. The embedded model is the way to go in this case. Now, I'm starting with let's say an edge case of the one-to-many relationship. If we are dealing with a small sequence of data that's associated with our documents, for example, here we might need to store several addresses associated with a given user. Again, because the number of elements in the array is limited, again, choose embedded model for this case. Now, the one-to-many relationship, this can be modeled in different ways using Amazon DocumentDB. And I'm using a different example here with a desktop computer product and its components. So the embedding of the parts in the product document means we can easily retrieve all the parts that belong to that particular product. And adding new parts is as simple as appending the new part document to the end of the parts array. However, there are potential drawbacks, which I've discussed already. So documents can grow too large and performance degradation with large number of array elements. For this case, where we know is going to be a limited number of parts, embedding is a good choice. However, imagine if our product is maybe an airplane with potentially tens of thousands of parts, embedding is not going to work very well. So the other option we have for one-to-many is to reference. In this case, we can keep the array of object IDs that link to the document that has the information about the part on the one side, because we don't have a large number of documents to link to. Along with keeping the document size small, another advantage of this model here is that it's much easier to paginate the parts listing, as the application can retrieve just a subset of the documents more easily. But in the other one-to-many edge case, when we have 1 to tens of thousands or 1 to millions or more, storing the reference on the one side is not going to work, since we will have a frequently updated and growing array. So as I have this a new example here, where for a server logging application, each server could potentially save a massive amount of data depending on how verbose you're logging and for how long you want to store the server logs for. So instead of tracking the relationship between the host and the log message documents in the host document, what you can do is store the host ID that the log message is associated with. So storing it on the many side of the relationship. By storing the data in the logs collection, we will not be affected this way by the unbounded array issue. For the many-to-many relationship, a good example is the relation between books and authors. An author might have written multiple books, and also a book can have multiple authors. In this case, we can include the book references under the books field, the books array in the authors collection. And similarly, in the books collection, we can include the authors references in the authors array. This is called the two-way embedding technique. Of course, we have to take into consideration here the amount of embedded references. We may have a situation of an uneven relationship. For example, if you want to model the relationship between category and books, a book may be part of several categories, but one category can have a large number of books. So in this case, model using the one-to-many relationship and reference on the many side, as I just described earlier. Now let's talk about design patterns, because design pattern is a technique that can be applied and reused multiple times for a multitude of use cases. I'm going to present in this webinar a few design patterns, 3 design patterns to be exact, the ones that I see used most often in practice. Now the first one, the subset pattern, this one solves the problem of having the working set exceed the capacity of RAM due to the large documents. And this usually happens because additional data was stored that is not actually needed by the application. Basically, when the embedded model was overused, it's one of my favorite design patterns because it solves very straight. It solves the problem of large documents in a very straightforward way. So if we take the example of the popular ice cream product, instead of storing all the reviews with the product document, we can split into 2 collections. One collection would have a subset of the data, the most frequently used data, for example, the most recent reviews, and in the other collection would have the less frequently used data, for example, the old reviews. This is the same technique implemented on the Amazon.com website. On the product page, we have the most recent reviews, and in order to see all the reviews, there's a separate link for which translates to a separate query in the reviews collection. Now, you'll apply this design pattern when you have a one-to-many or many-to-many relationship, and when the documents are starting to become too large. This will lower the overall size of the working set, reducing the memory constraints. The downside, as discussed when using the referencing model, the additional database round trips which are needed to retrieve all the data. Article or blog comments, actors in movies are other examples for using this pattern. For example, the example I like to give is in a movies collection, we can store just the main actors for each movie document, just a subset, while in a separate collection, actors will store the complete cast. Typical use cases for this design pattern can be catalogs, content management, mobile, or personalization. Now, the next design pattern I wanted to show is the pre-compute pattern. And to showcase this, let's say we have a new feature that we want to implement to our application, which is to calculate the average rating for the products. So we already have in the reviews collection the rating entered by the reviewers. So to calculate the average rating, this means the application will have to do many reads in the reviews collection in order to calculate the total sum of all ratings for a product and then divide by the total count of reviews for that particular product. And you'll have to do this each time the average rating is needed. Well, that can be a lot of CPU cycles, as you can imagine. Well, instead, what you can do is update 2 new fields in the product document. Each time a new review is added, update the total sum and the count, the number of reviews. This way, the average rating is very easy to calculate by the application just by fetching the product document, and then the division is very easy to calculate. Of course, this is a simplified example, but the computed pattern can be utilized whenever calculations are needed to be run against data. Whenever you're doing sums, grouping, aggregations in a repeated fashion or very often, or when the application is read intensive. In this case, the computations can be amplified, and it's putting a lot of stress on CPU, memory, or I/O. By applying this pattern, you are reducing or avoiding repetitive processing, and queries become simpler and faster. Typical use cases for this design pattern are, again, catalogs, IoT, mobile, or real-time analysis. Now, the last design pattern I wanted to talk about is schema versioning, which is probably a must-have for all use cases. Regardless of the reason behind the change, after a while, you'll inevitably need to make changes to the underlying schema design in your application. And while this doesn't possess such a challenge as in tabular database system, in DocumentDB, we can use the schema versioning pattern to make the changes easier. The implementation is relatively easy. So in this example, a decision was made to apply a new schema and move the attributes of the product as subdocuments in an attributes array. When that occurs, you can create and save the new schema to the database with a schema version field. This field will allow your application to know how to handle this particular document. We can assume that the documents that don't have this field are version 1, and each new schema version would then increment the schema version field value and could be handled accordingly in the application. Now, inside the application, you would need to create functions for handling each schema version. To update all documents, you can batch update in the background from one schema to another. And the flexibility of Amazon DocumentDB model allows for all of this to occur without downtime of the database. The schema versioning pattern is great for when application downtime is not an option, and updating the documents may take hours, days, or weeks to complete. Additionally, it provides the developers the opportunity to better decide when and how data migrations will take place, or also, and this is one of my favorite, you can enable certain feature flags on a subset of documents. Things to consider with schema versioning, though, would be that new indexes may be needed for the new fields, which will have to be maintained until all the documents are updated to the new schema. So finally, I wanted to end this webinar with showing you what we usually see as being the data modeling journey. When you have a small project, you are a startup, you just had an idea, and you start developing an application, you probably lean towards the simplicity of the model. When you size the workload, you'll check and identify the most used queries, making sure those are covered by indexes and the data model is efficient for those. And the preferred model would be embedding, while also applying one or maybe two patterns. Of course, in time, new features are added, the size of the team grows, the application has matured, but also becoming more complex. And performance, in this case, plays a major role. At this level, when sizing the workload, you'll take more things into consideration. You'll identify all the queries, quantify, but also qualify the operations. How many reads, how many writes, what are the most important queries for the application, things like this. Modeling, most likely, in this case, would be a mix of embedding and referencing. And you also, of course, apply more patterns for the best performance and optimum resource usage. With that, I want to thank you for your time and for joining this webinar about data modeling with Amazon DocumentDB. I hope it was useful and it has given you a better perspective on how to model your data for optimum performance and cost. Thank you very much.